Hello class, in section 8.5 we're going to be using the distributive property. Actually, we're going to be doing the reverse of the distributive property, and we're going to be doing a little something called factoring. So let's review what we already know about factoring. If I wanted to factor, let's start with number 3, 36d to the third f squared. I would start by, I like a factor tree where we would say 2 times 18 is 36, which is 2 times 9, which is 3 times 3. So the factored state of 36 is 2 times 2 times 3 times 3, and then of course d times d times d times f times f. So that would be the factored form of number 3. And then number 4 says, what is the greatest common factor of 4a squared b? So that would be 2 times 2 times a times b. Then the second one, 8, would be 2 times 4, which is 2 times 2 times 2 times a times b. And then the third one would be -1 times 2 times 2 times b times b times b. So we're going to take out the greatest common factor. They all have 2 2's, 2 2's, 2 2's, and they all have, well, this one doesn't have any a's, so a b, and a b. So the greatest common factor for this problem would be 4, which is 2 2's b. 4b is the greatest common factor. Alright, so with that in mind, let's get into our new material where we're going to talk about using the distributive property. So our first new term is just factoring, which is what we just did. In this section we're going to be factoring, which is writing the original term as a product of its factors. Then we're going to also work on factoring by grouping. And you'll see what that looks like in just a moment. Putting terms in groups in order to factor it. And then we're going to also talk about what the zero product property is. And it's if the product of two terms equals 0, then at least one of those terms has to be 0. And again, this will make more sense when you see some example problems. So let's just talk about the distributive property. Here I would take 5z and I would distribute it to everything inside parentheses. So 5 times 4 is 20, and z times z is z squared, plus 5z times 7 is going to be 35z. Well, the reverse distributive property is where we take out what the greatest common factor between the two numbers are, which we already know it's 5z. So 20z squared plus 35z, if I gave you that first and asked you to factor it to do the reverse of the distributive property, then you would say, we'll take the 5z out, and then you'd have the 4z plus 7 left to be multiplied. So that's the reverse distributive property. That is called factoring. We factored out the 5z. So let's see if we can use the reverse distributive property to factor these problems here. So what is the greatest common factor between 15x and 25x squared? Well, they're both divisible by 5 and they both have an x. So if I take out the 5x, I have 3 left. I'm dividing. 15x divided by 5x leaves me with 3, and 25x squared divided by 5x leaves me with 5x. I believe that's my final answer, but I can check my status by distributing and seeing if I go right back to where I started. So that would be 15x, yes, and 5x times 5x would be 25x squared. So I was correct. So this was my checking it. You do not have to check, but it's a great idea. In number 3, between all three of these, 12 doesn't go into 30, but it does go into 24. 4 goes into 12 and 24, but 4 doesn't go into 30. So I think 3 is our greatest common factor that's not a variable. and I see an x in every problem, and I see 1y in every problem. So if I took out a 3 here, divide by 3, you get 4. xy, I took both of those out. When you divide 12xy, come over here, 12xy divided by 3xy, you have a 4 left over. When I say 24xy squared divided by 3xy, I have an 8y left over, minus, keeping the sign here, 10. X cancels with one of those x's and y cancels with one of the y's, and that would be the factored form. Again, to check myself, I just go back and say, when I multiply 3xy, do I get 12xy? Do I get 24xy squared? Do I get negative 30x squared y to the 4th? And I believe I do, so therefore I will stick to my answer. I'm going to leave 2 and 3 for you to check yourselves. See if you could factor those. All right, our second new term was called factoring by grouping. A polynomial can be factored by grouping only if all of the following conditions exist. So you have to have all 3 conditions. There have to be 4 or more terms. The terms have common factors that can be grouped together. So we're looking for common factors again. And there are 2 common factors, 2 common factors that are identical. Or, if they're not identical, they're at least additive inverses of each other. So we will show you what this looks like. Here they have it with ax plus bx plus ay plus by. So in the first 2 terms, they factored out the x, and they have a plus b. The second 2 terms, they could factor out the y, and they have a plus b. So now we can factor out an a plus b. Both of these terms have a plus b in common. So think of it as if you factored out one term, an a. If these were both a, then you could pull an a out. When you pulled a out, what would you have left in parentheses? X plus y. Let me see if it makes better sense when we have some numbers. What can I take out of 2xy and 7x? The only thing I can factor out is x. So 2y plus 7 is left. Now remember, there's no such thing as subtraction. That is plus a negative 2y. So I'm going to put a plus. What can I take out of negative 2y and negative 7? The only thing I can take out is negative 1. So when I factor out a negative 1, I have 2y plus 7. Oh, look, this is the same term, 2y plus 7. So x plus a negative 1, which is minus 1. I have that here. Oops, not plus. Times, because we're actually undoing the FOIL method if y'all haven't figured that out. So 2y plus 7 is the common factor. Maybe I should have written that first. See if it makes better sense if I write the 2y. So what can I take out of both of these terms? 2y plus 7. When I take this out, treating it as if it was one term that I factored out, then I have left x minus 1. Again, we can check ourselves. Do the FOIL method and see if you end up with the term that we started with, and I believe you will. Okay, I'm going to let you try number 2 on your own. Don't panic. We'll spend a couple of days on this. Factor by grouping with additive inverses. Now let me show you what additive inverse looks like. Between 15a and negative 3ab, I can factor out a 3 and an a. So that leaves me with 5, because 5 times 3a would give me 15a, minus b. I'll give you a little hint. I want my other set of parentheses to be 5 minus b, especially if I know I'm factoring by grouping. So between these two, I can factor out a 4. When I pull out my 4, I have b left minus 5. Oh, it's close. 5 minus b, b minus 5. Those two expressions are additive inverses of each other. If I can factor out a negative sign, if I take out, let's leave the 4 there. If I take out a negative 1, I change the signs. If I take a negative 1 from positive b I need it to be a negative b, and take a negative 1 from negative 5 and make it a positive 5. See how you can check that? Negative 1 makes it negative 5, negative 1 would make that positive b. So what really happens is I have 3a times 5 minus b minus 4, because positive negative here makes negative 4, 5 minus b. And I want to have the same term. Now I can factor out the 5 minus b out of both terms, and I'm left with 3a minus 4. Again, do the FOIL method to check to make sure you end up with the same answer. I'll let you practice number 2 on your own. Now, the zero product property, I think you're going to like this. This is fairly simple concept. If the product of two factors is 0, then at least one of the numbers has to be 0. Anything times 0 equals 0. For any real numbers a and b, if a times b equals 0, then either a had to be 0 or b had to be 0. Or they could both equal 0. So look at number 1 here. For the multiplication of these two binomials to equal 0, one of these had to be 0. If x minus 2 was 0, then whatever this turned out to be times 0 equals 0. So we have to check for all possible solutions. So we're going to say, what makes x minus 2 equal 0? 2. If you plug in 2, you get 0 times, actually that'll be 8 minus 1, which is 7. And 0 times 7, guess what that equals? 0. Then you have to also say, well, wait a minute, what about if 4x minus 1 was the 0? Well, you add 1 to both sides, so 4x equals 1, divide both sides by 4, and x equals 1/4. So 1/4 of 4 is 1, and 1 minus 1 is 0, and 1/4 minus 2 is going to be a negative 1 3/4. But when you multiply times 0, even though it's an ugly fraction, it's still going to turn out to be 0. So we say here the answer to this situation, the roots of this problem, what makes this 0, are 2 and 1/4. So together those are your roots. I'm going to leave number 2 for you to check. I'm going to show you how you'll manipulate number 3. First thing I need to do is subtract 4y from both sides. And I can't subtract 4y from y squared because they're not like terms. So that makes the new problem 0 equals 12y squared minus 4y. Alright, well y could be any number of things, but I want it to be a number that makes 0. And I'll give you a little hint. When our y is squared, that means there's 2 possible solutions because I can factor. So the greatest common factor between 12 and 4 is 4. Between y squared and y is y. So when I factor out a 4y, it still is going to be equal to 0. I have 3y minus 1. Okay. The question here is what is going to make 4y equal 0, because 0 times anything is 0, and what's going to make 3y minus 1 equal 0? Well, when you divide by 4, remember when 0's in the numerator, then your answer is 0. If it had been in the denominator, it'd be no solution. So y could be 0, or when I add 1 here and divide by 3, I end up with 1/3. So our solution to number 3, the roots, are 0 and that should be an equal sign. Okay, 0 and positive 1/3 are our roots for number 3. I'm going to let you also check number 4 because you're going to have to factor out a 5x just like I did and find out what numbers will make for 0. And in our last 30 seconds, let's look at this word problem where they give us the equation for a football kicked in the air. And this is how you would calculate the height of the football. And they want us to find the values of x when h is 0. So the equation I'm solving is this. I can factor out a negative 16x or a positive 16 and then solve for the zeros, which are 0 and 1. All right, you try number 2. Have a great day.